Here are some facts that can be useful when working with the population variance. The first is the units on the population variance are the square of the units of the random variable x. So if x is measured in, say, meters, then the population variance sigma squared will be meters squared. If x is measured in minutes, then the population variance will be minutes squared. And this leads us to another measure of dispersion, which is the positive square root of the population variance is known as the population standard deviation, sigma. Again, the word population keeps appearing. That's because there is something known as the sample standard deviation, S, from statistics, and they are different creatures, although they are related. The units on the population standard deviation are the same as the units on the random variable x. So again, if x is measured in meters, then the population standard deviation is also in meters. Next, if the discrete random variable has a support set script A that contains only one point, then sigma squared equals 0. Go ahead and write an example of such a distribution. Here the probability density function is 1, and it is 1 at just a single point in the support set. And let me just make up 17 as that point. This is a distribution that can only assume the value 17. The only thing the random variable can do is be 17, which means all of its mass is at 17, and what that means is the population standard deviation is 0. This distribution is known as a degenerate distribution. Some authors will also use var of x for the population variance, so you'll see that in other textbooks and out in the probability and statistics literature. The population variance and the population standard deviation are not the only measures of the dispersion of a random variable x. Here are two other measures which are much less popular. The first is the population range R, and that range will be the supremum of the support set A minus the infimum of the support set A, basically just the range of the support. And then the other one is the population mean absolute deviation, which is sometimes abbreviated MAD, and that will be the expected value of the absolute value of x minus mu. Again, instead of squaring, you can use an absolute value here, and what that does is that will put less emphasis on probability or support values that are far away from the population mean mu.